Good evening, students. How are you? Hope you have enjoyed your day. So now it is study time. I am Dr. Smrutirekha and I welcome you all to Etuson, Education for Better Tomorrow. Etuson is a digital learning platform for Odia and English medium students developed in Odisha. It has live classes, interactive classes. We have test also, mentorship also, and many more things. For that, you have to download the eTuition app so that you can enroll yourself. So don't delay. Please download the app and enroll yourself. Correct? So now let us go to today's topic, which is real number. Already we have discussed some of the concept of real number like concept of real number, Euclid division lemma and Euclid division algorithm. So today it is the fourth class related to real numbers in which we will be solving some of the problems on the concept which is already discussed. So before going to the uh, topic, let us revise what we have studied in the previous class. Okay, so what we have studied? So as I was telling you, we have discussed Euclid's division lemma and Euclid's division algorithm. So basically what we do in Euclid's division method, so we express one positive integer in terms of product of two integers and another integer is being added to it where your q is an integer, positive integer, and r value lies in between your 0 and b. That means remainder can be equal to 0 but it should be less than your b. Okay, so when this remainder becomes 0, that time this b becomes b is HCF of a and b. Correct. So by using your Euclid division algorithm, we can find out the HCF of numbers. So we have already discussed some of the problems in the previous class. So today first we will discuss some of the typical problem related to Euclid division lemma and algorithm. Then we will solve your exercise problem that is part of your NCERT book. Correct. So let us go to the typical problem which mostly asked in the exam. What is it? So that every positive even integer is of the form 2q and that every positive odd integer is of the form 2q plus 1 where q is some integers. So it is very simple. So how you are going to start it? So for that, so what we will do? So we will consider letters, take A as an positive integer. Okay. And B is equal to 2. So according to your Euclid division lemma, what you can write? You can write A is equal to 2q plus R. Correct or not? A is equal to 2Q plus R. Now this R value lies between your 0 and 2. So what do you mean by that? So it means that R can be equal to 0 or R is equal to 1. If your R is equal to 0, then how you are going to write the value of A? In that case, your A is equal to 2Q. So because Q is multiplied with 2, so that means with this expression, what you can derive from this expression is 2 is a factor of A. 2 is a factor of A. So definitely A is an even positive integer. Correct or not? A is an even positive integer. If R is equal to 1, in that case your value of A will be 2Q plus 1. As we know that in case of integer, integer can be either positive, even integer or odd integer. If 2Q is even integer, then definitely your 2Q plus 1 is an odd integer. Correct or not? Yes. It was very simple, right? Just by using your Euclid division lemma concept, you could prove it. So let us go to a similar kind of problem in which what you have to show? You have to show that any positive odd integer is of the form 4q plus 1 or 4q plus 3 where q is some integers. This problem is also similar to the previous problem. So only difference is in the previous problem we have taken b is equal to 2. Here what you are going to take b as? So here instead of 2, b will be equal to 4. That is the major problem if you compare with the previous problem. So let us write it. So here like in the previous example, so what you will do, you will take let a be an integer which is positive. Correct? Okay, so now what you will consider, and b is equal to 4. So now you can write down a is equal to 4q plus r, where this r value lies between your 0 and 4. So that means what are the possible values of your r? R is equal to 0, r is equal to 1, it can be 2 and it can be 3. So when your r is equal to 0, a is equal to 4q. When r is equal to 1, a is equal to 4q plus 1. When r is equal to 2, a is equal to 4q plus 2. When r is equal to 3, a is equal to 4q plus 3. Correct or not? So now from this expressions, you can observe in case of your a is equal to 4q and A is equal to 4q plus 2. It is factor of 2. Correct or not? It's a factor of 2 because you can write it as 2 into 2q, and here you can write it as 2 into 2q plus 1. So what does it indicate? That means these two numbers, that is 4q and 4q plus 2, are even integers. So as we know, if one integer is not even, it is odd integers. So it is proved that so it is proved that 4q plus 1 and 4q plus 3 are not even. They are odd integers. It's quite simple. Correct. So these are some of the typical problem uh, which comes in the exam, and also there are some problems like this in your exercise also. So today let us discuss some of the problem which is there in your NCERT exercise 1.1. So your first question is, use Euclid's division algorithm to find the HCF of the following number. So we will take the first one, is where we have to find out the HCF of 135, and so you have to find out the HCF of 135 and 225. So 135 and 225. So as you can see here, 225 is greater than 135. So you can express 225 in form of BQ plus R. So for that, for better understanding, I am writing in form of division, so that you will come to know what should be taken as quotient, what should be taken as remainder. So I know all this you know, but still for better understanding I am just writing it up. Okay, so 135 here, so you write 1 here, so you will get 135, and the remainder is how much? Remainder is 90. So because remainder is 90, so let us write down the first expression in terms of your Euclid division algorithm, that is 225 is equal to 135 into 1 plus 90. So here remainder is not equal to 0, it is 90, correct? So you have to go for the next step. So in the next step, your 90 becomes the divisor and 135 becomes the dividend. So you write it here. So here 135, you write 90 here, and the remainder is 45. Again the remainder is not equal to 0. So let us write down here in form of Euclid division algorithm. So 135 is equal to 90 into 1 plus 45. So as the remainder is not equal to 0, we have to go to the next step where 45 becomes your divisor and 90 becomes your dividend. So 45 into 2 is equal to 90. So 90 minus 90 is equal to 0. So now your remainder is equal to 0. So let us write down here. So here, so 90 is equal to 45 into 2 plus 0. Correct. So here HCF is equal to 45. So you can write it down like this. So HCF of 225 comma 135 is equal to HCF of 135 comma 90 is equal to HCF of 90 comma 45, and the answer is 45. Correct. So this is how you will find out the HCF of these two numbers. So this was your bit 1 of question number 1. So let us go to the next question. So what is this? That is, you have to again find out the HCF of 196 using Euclid division algorithm. So let us check with this. So 196, here 196, correct. So 12 minus 6 is 6, 186. So this 2 will come down. It is simple division. Nothing to worry. This you are doing from your third standard onwards. This is nothing great I am doing. Right? So 1862 into 9. Okay. So it is 1764. Okay. Now we'll subtract it. It is 8. And here it is 9. This 0 will come down. So this becomes 980. And here comes your final number, and your remainder is equal to 0 here. So you are lucky here. So what is the HCF of these two numbers? So the HCF is 3820 comma 196, that is equal to, what's the HCF? HCF is equal to 196 itself. If you write down in form of Euclid division algorithm, because that you have to do compulsorily, because it is written that you have to solve it by Euclid. Already you have done it, but you have to write the expression also. So how you are going to write? So first you will write like this, as 38220 is greater than 196. So you will write down like this, 38,220 is equal to 196 into 195 plus 0 as the remainder is equal to 0. So HCF is equal to your 196. Correct. So this was your bit 2 of question number 1 of exercise 1.1. So now let us solve the next problem. So what is it? You have to find out the HCF of 867 and 255. So again the same procedure. So here 867 is greater than 255. Right. So I will write 867, 255. So it becomes 3, 765. Correct. So 102 is the remainder, which is not equal to 0. So let us write down the first step, that is 867 is equal to 255 into 3 plus 102, where remainder is not equal to 0. So now the remainder becomes your divisor and 255 becomes your dividend. So here comes your 2 as quotient and you will get 204 here, and your remainder is equal to 51. Correct. Again it is not equal to your 0. Correct. So let us write down in form of Euclid division algorithm. So you will write 255 is equal to 102 into 2 plus 51. Correct. So which 51 is not equal to 0. So you have to go further. So 102 becomes your dividend. Now you check. So you multiply 2. 2 becomes your new quotient and your remainder becomes 0 here. So let us write down the final step. So where 102 is equal to 51 into 2 plus 0. So your 51 is the HCF. So how you are going to write it? So HCF of 867 and 255 is equal to HCF of 255 comma 102 is equal to HCF of 102 comma 51 is equal to what? The answer is 51. So I think now you are clear in finding out the HCF using Euclid division algorithm. Correct. So now let us go to the next problem. So it is similar to the typical problem which we discussed today. That is, so that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. So here what is the difference between this problem and the previous problem which we have discussed is, here instead of 2 or 4, b will be equal to 6. So like in previous example, so we will take a is equal to, so here b is equal to your 6. So let b is equal to 6 and a is positive integer. So I am not writing in detail because we have already discussed same type of problem. You can refer to that. So for your understanding, I am just writing it down. A is equal to, b is equal to 6 now. So that is 6q plus r. So now q is some integer, q is an integer, positive integer, and what about r value? So r value, it lies between 0 and 6. It is less than 6. So what are the possible values of r? So it is 0, 1, 2, 3, 4 and 5. Correct. 0, 1, 2, 3, 4 and 5. So now one by one we will take the r value. If r is equal to 0, your a is equal to 6q. What is 6q? It is 2 into 3q. So that means it is an even integer as it is a factor of 2. Correct or not? Now suppose r is equal to 1. Then what will be your a value? A is equal to 6q plus 1. So if it is, so definitely it is not factor of your 2. So if it is not a factor of 2, it is not an even integer. That means it is one odd integer. Correct. Now you take r is equal to 2. It implies a is equal to 6q plus 2. This can be written in this form, 2 into 3q plus 1. Again it is a factor of 2. So definitely 6q plus 2 is even integer. Correct. Now you take r is equal to 3. if r is equal to 3, so your a is equal to 6q plus 3. So here if you want to take common, you can take 3 common here. So that in that case it becomes 2q plus 1. It's not a factor of 2. So it is not an even integer. It is odd integer. Correct. So similarly, if you take r is equal to 4, a is equal to 6q plus 4. So that is equal to you take 2 as a common factor, so you will get 3q plus 2. Again it is factor of your 2, so it is one even integer. Correct. So 2 is a factor, so it is one even integer. Now you take r is equal to 5. So it becomes a is equal to 6q plus 5, which is not an even integer. So if it is not an even integer, so it will be odd integer. Correct or not? So what are your odd integers now? So you got that 6q plus 1, which is this, 6q plus 3 and 6q plus 5 are odd integer. Correct. So this is how you will solve this kind of problem. Now let us go to the next problem, that is question number 3. So let us see what is there in question number 3 for you. Okay. So let us read the question first. An army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? So it is very simple to find out the maximum number of columns in which they can march. You have to find out the HCF of these two numbers, that is 616 and 32. So you can write down like this: members in an army contingent is equal to 616. Members in a band is equal to 30. Maximum number of columns is equal to HCF of your 616 and 32. So how you are going to do it? Simple, by division method. So let us divide it. So 32, 1, 32, you will get 11 minus 2 is 9. You will get 2 here, 296. So you will suppose it is 9, 10, 8, 1, 288. The remainder is equal to 8. So let us write down in Euclid division algorithm. Your 616 is equal to 32 into 19 plus 8. So remainder is not equal to 0. So the remainder becomes divisor, and 32 becomes your new dividend. So 32 divided by 8, it is divisible, so you will write 4 here, and the remainder is equal to 0. Let us write down in form of Euclid division algorithm. So 32 is equal to 8 into 4 plus 0. So what is the HCF? So HCF is equal to 8. So your answer is 8. So the maximum number of column they can merge is equal to 8. So children, I think question number 1, 2 and 3 is clear for you. Okay, so that much for today. So the rest problems we will discuss in the next class. Thank you students for your patient hearing. Please follow us in YouTube, Instagram, Facebook, Twitter. You can visit our official website, and don't forget to download the app. And very soon we are coming up with the live classes where you can solve many more problems and you can clarify all your doubts. Okay, take care.